Hello! In this video, we're going to look at color changes for the reactions of transition metal ions in aqueous solution and their precipitates as required for Edexcel A-level chemistry. The specific ions covered will include Fe2+, Fe3+, Cu2+, Cr3+, and CO2+, as well as the colors for vanadium 5, 4, 3, and 2 oxide complexes. Ligand substitution reactions for copper and cobalt complex ions will also be covered. Fe2+, Fe3+, Cu2+, Cr3+, and CO2+ ions all dissolve in water to form metal aqua complex ions, each of which produce different colored solutions. Fe2+ ions form the metal aqua complex ion FeH2O6 2+, and a green solution. The ion has an oxidation state of positive 2. Fe3+ ions form the metal aqua complex ion FeH2O6 3+, and a purple solution. However, the solution may end up looking more yellow due to the formation of some FeH2O5 OH2+ ions. The ion has an oxidation state of positive 3. Cu2+ ions form the metal aqua complex ion CuH2O6 2+, and a blue solution. The copper has an oxidation state of positive 2. Cr3+ ions form the metal aqua complex ion CrH2O6 3+, and a pale purple or violet colored solution. The color will change to green when heated, and due to impurities, it is common for Cr3+ ions to give a green solution at room temperature. The chromium has an oxidation state of positive 3. CO2+ ions form the metal aqua complex ion COH2O6 2+, and a pink solution. The cobalt has an oxidation state of positive 2. If sodium hydroxide or ammonia solution is added dropwise to any of these solutions, metal hydroxide precipitates form. The iron 2 solution forms iron 2 hydroxide FeH2O4 OH2 that is green in color. The precipitate may turn brown over time. The iron 3 solution forms iron 3 hydroxide FeH2O3 OH3 that is brown in color. The copper 2 solution forms copper 2 hydroxide CuH2O4 OH2 that is blue in color. The chromium 3 solution forms chromium 3 hydroxide CrH2O3 OH3 that is green in color. And the cobalt 2 solution forms cobalt 2 hydroxide COH2O4 OH2 that is blue in color. If sodium hydroxide solution is then added in excess, the green chromium 3 hydroxide precipitate previously formed redissolves and the complex ion CrOH6 3- gets formed, producing a green solution. The other metal hydroxide precipitates remain unaffected by the addition of excess sodium hydroxide. If ammonia solution is then added in excess to any of the metal hydroxides, the copper, chromium, and cobalt hydroxide precipitates all redissolve. For copper, the light blue copper 2 hydroxide precipitate redissolves and a dark blue solution containing CuNH3 4 H2O2 2+ complex ions gets formed. For chromium, the chromium 3 hydroxide precipitate redissolves and a purple solution containing CrNH36 3+ complex ions gets formed. And for cobalt, the cobalt 2 hydroxide precipitate redissolves and a yellow solution containing CONH36 2+ complex ions gets formed. The other metal hydroxide precipitates remain unaffected by the addition of excess ammonia. Vanadium can form ions with different oxidation states. When a solution of ammonium vanadate 5, NH4VO3, is reduced using zinc metal under acidic conditions, color changes can occur, and the final color of the vanadium compound depends on the oxidation state of the vanadium in the complex ions formed. If the vanadium has an oxidation state of positive 5, the solution is yellow and the complex ion is VO2H2O4+. If the vanadium has an oxidation state of positive 4, the solution is blue and the complex ion is VOH2O5 2+. If the vanadium has an oxidation state of positive 3, the solution is green and the complex ion is VH2O6 3+. And if the vanadium has an oxidation state of positive 2, the solution is purple and the complex ion is VH2O6 2+. Copper-2 metal aqua complex ions can undergo ligand substitution reactions and color changes occur. If copper-2 metal complex ions undergo ligand substitution with chloride ions, CuCl4 2- ions and water get formed. The solution changes in color from blue to yellow. If copper-2 metal aqua complex ions undergo ligand substitution with ammonia, CuNH3 2+ ions and water get formed. The solution changes in color from blue to dark blue. Cobalt-2 metal aqua complex ions can also undergo ligand substitution reactions and again, color changes occur. If cobalt-2 metal aqua complex ions undergo ligand substitution with chloride ions, CoCl4 2- ions and water get formed. The solution changes in color from pink to blue. If cobalt-2 metal aqua complex ions undergo ligand substitution with ammonia, CONH3 3+ ions and water get formed. The solution changes in color from pink to yellow. Cr3+ ions can be oxidized to CrO4 2- ions using hydrogen peroxide and hydroxide ions, H2O2 and OH-. The solution will change color from green to yellow. CrO4 2- ions can then easily be converted to Cr2O7 2- ions with the addition of H+ ions. The solution will then be an orange color. Cr2O7 2- ions can be reduced to Cr3+ ions using zinc metal and acid, a source of H+ ions. The solution will change color from orange to green. I hope you found this video useful. Please check out other relevant videos in the description below and visit chemistrystudent.com for free notes and resources.